Good afternoon, everybody. I'm Tony Balkwill. I'll be presenting today with Nick Winkler and Cory Muhlbauer. And yeah, so our discussion title, Real Results, Real Insights, Radicle Research. I'm pretty much managing all the field trials across North America, some internationally now as well. We're going to kind of go through basically the stage of those, touch on a few results, kind of have a discussion about some of our future research coming down the pipe in the next years and years ahead. So some of you are current collaborators and partners with the field trials, and some of you are interested in them. So it's kind of a nice mixed group. But that review will go over and kind of like the discussion this morning, the opening remarks, you know, this word innovation can be kind of a big daunting word. If you looked up it in an actual definition, it adds to a lot of things, but you know, sometimes it's the little things that make a big difference. And kind of with the Radicle team and all the stuff we've done over the past and in the future, you know, this is kind of where this product line and everything we're doing is leading. But I'll just tell you a small story about innovation, and again, it's just the small things that can make a big difference. So back in my first year at university, staying on campus, of course, they assign you a roommate in a dorm. Now, I'm dating myself, it's going back 20 years ago. But, so the first week of university isn't really about going to university. It's about going out to parties and meeting your fellow students and things like that. So the first night at university, or a couple nights in, we're going out to a party. Stop by an ATM, a bank machine, to get cash, because that's how it worked back in the day. I noticed my roommate, he's going through the trash can. I'm like, wow, I really got a good one for the first year. So we go to this party, end of the night, midnight to the morning, I don't know, we get back, and I kind of say to him, I was like, well, how'd you do? Did you meet any girls? Did you get any numbers? Things like that. He's like, well, I don't get girls' numbers, I just give them mine. I was like, man, I don't know how you think this world works, but that's not been working well for me at all. But what he would do, he'd go through the trash can at an ATM machine, and he'd pull out these receipts with enormous balances. He'd write his number on the back. And that's what he would give the girls. Okay. So it's the little things in innovation that can have big results. When we talk about the research and learning today, you guys have seen some pretty amazing engineering, some technology. But when we look at the research, when I kind of peel this all back and discuss this today, the soil test is just one part. Now, you heard the term nutrient management. Me as a grower, where I'm from, you know, we look at our fertility as a system. So what tools are we using? Placement, product, all of that stuff goes into the trials. That is the interesting stuff that these trials have a huge, huge weight on. So we are looking at the basics, part per million change by pound, crop removal, you know, re-looking, retooling, all of those numbers, all of your state recommendations, all of that stuff, just taking a completely fresh perspective with it. But looking at a lot of other things, placement, all of that stuff, liquid, dry, what product are you using? The unique thing about these trials is that they're your trial. They're done with your equipment, your field, you pick the field, right? It's your soil type, it's your geography. And that's kind of the power behind that with these trials. Collectively, we have lots on the go. But individually, you can learn a lot just from your field within seasons, kind of committing and working with us on that. It's kind of a big overview, big map of currently what trials we'll have in play. Now, right now, we're focused on phosphorus and potassium, and we hope to expand that into about 200 trials. So you can see here kind of the distribution of the trials up through where I'm from, Southern Ontario, and right through multiple states, east, west, south. You're going to keep building that. There's a bit of a process to these trials, and for a lot of reasons. If you look at it from a big picture point of view, fertility trials are not singular year trials. It takes time, it takes commitment, things change in our farms over those years that these trials are trying to adapt to. You kind of look at a starting point with this, collaborating with us. It all starts with just a field boundary. It's your field, it's your choice. As you submit one of these, you kind of start walking through the process. You can submit a few fields, we can pick one that's ideal. If it's variable, if it's even, it's your trial, we just support you with that choice. Then we give you the points. And if you notice something unique about these points, they follow no grid pattern whatsoever. And we'll talk about that in a little bit, why that's important. We supply the points on where to take the trial test points, and those will be the base points that you would initially pull. So those will go through the Radicle lab, and those are the benchmark tests that I'm going to start with in that trial. Then I'll build you a prescription. Now this is specific to your product, your applicator, your choice, liquid strip till broadcast, doesn't matter. And you'll notice something very unique about this prescription. It's perpendicular to the path or the AB line of your field. The reason for that is during the evolution of multi-year field trials, growers upgrade equipment, change. I get a 90-foot applicator one year, I get an 80-foot, I get a 60-foot, then you change to strip till. All of these stuff we try to account for just to smooth it out. And you'll notice that we have zero rates in the field. So not to scare you on that, but that's a necessary evil for the fertility trial world. We want to see some of those points be drawn down. We want to see what the crop removes. On the flip side of that, we have really high rates. We have 300s and those type of numbers where we want to see what that maximum kind of rate return is on those fields. And as you'll notice, the points are centered. They're weighted in the dead center of a lot of those rates. Equipment does not change instantly with a rate. Valves and drives and PWM work on, applicators and stuff take time. So there's a lot of flow and buffer between rates. Because these rates aren't ramp rates, which means they're not zeros up to highs and lows, they're very quick, hard rate changes. So you get a lot of flutter in between those rates. So the center of that rate zone, if it were, that point is dead center in the middle. So we have a lot of buffer in there to give us the accuracy of the rate being in the middle, being the most logical rate or the most accurate rate of that volume. Then in the spring, we'd resample. So remember, we did a baseline fall, we did an application, and then we test again. And this starts building our data set. Just simple part per million movements on soil tests, different rate numbers, and all of that stuff. We just start aggregating and collecting that data. Then in the summer, after that, in the season, it's just you as a farmer farming. Hybrid of choice, nitrogen program, all of that stuff. All we ask within these trials is the communication and information of what you're doing in the field. If you're a manure guy, if you've got pea on the planter, all of that stuff just needs to be collected and managed within the trial. We just want to know. And then one important part is our yield data. We really want to get the yield data from that farm. And we're not looking at all of the yield data. I'll explain to you just in a second how we kind of are going to zero in on just the specifics of it. But this is important parts as well. We want to bring in this aggregated yield data, be able to see and start putting together big data sets on actual crop removals, things like that. And you can see kind of a superimposed script on top of that yield map itself. So one of the things with the yield data is we don't need all of it, right? So I'm going to bring in all the data. But again, similar to the application rate of fertilizer equipment, you know, a 12-second delay in the mass flow meter in a combine changes a lot as you go through. So as a combine transitions between a 0 and a 300, there's a bit of flutter there when it starts logging points every second. So ideally, when we look at the yield data, we're basically doing the nearest neighbor approach. We're going to capture 100 feet, 200 feet, depends on the size. But we just want the obvious points around that soil test point. We want the obvious yield data points. That was basically the ideal, or sorry, it was the actual application rate that was applied, right? The as-applied map from an applicator and the prescription that I build don't always look the same, do they, right? So we need that quality control to actually what hit the ground from a rate. And that's why we just keep focusing in and being sharper and sharper when we do the data analysis on these. To that point, we don't always get it right the first year. When we see areas like this, where our point choice was a bit out of bounds as far as the potential of a high and low yield, we'll slide in extra points, corrective points, we can delete points, all of that stuff. Okay? The more information we can glean on a field, the better the project is. So there's always opportunities every season moving forward to kind of pick up those little anomalies within fields. So one unique thing about a dynamic trial is as it grows, so now we're into kind of third year, fourth year, is our zero rates don't always live as a 0. When you do a dynamic trial, it always will at some point add an inverted script. So an inverted script basically is all of a sudden my zero becomes a corrective rate, 200 pounds, 300 pounds, 380 pounds. But those zeros that we basically mine down over a few seasons, we then flip them back into a high application or a corrective application. On the same point, my 300 doesn't leave 300, it doesn't stay 300 forever. At some point, enough's enough, we go back to a zero. We might drop our 300s 2 years in, we might mine a zero as long as you're comfortable with it. It really just depends on your system, soil type, products you're using, rotation, all of those stuff. Each trial has a very, I would say that each trial is very custom to how you're farming that field. We can kind of work with it over the years. But at some point, this will happen on the trials to kind of rebalance them, or to be able to kind of look at a different format within the trials from a data evaluation. So just kind of regrouping here our different distribution, and the trials are cool in the way that like you have different generations. Some of these are about 3 years in, some of them were 2 years in, and some of them were just starting. But one of the unique things you'll notice is that it's never really done before in a lot of these fertility research trials, is we're really looking at tillage systems within this. It's funny because I think a couple of weeks ago, like ChatGPT, which apparently looks at the entire internet, I Googled and said, all right, tell me where there was fertility placement trials, published reports, white papers, and stuff. And I found like two of them in the 80s, done by Ohio State, some other obscure university. There was nothing in a field scale system. Now, maybe strip-till wasn't around in the 80s, so I get it. But this is an important part. These are the tools and methods that you as growers use. They should be a key component of these fertility trials. Not everybody's broadcasting, not everybody's no-till, and stuff like that. There is a lot of data being pulled out in one of these trials. So you think about here a spring and fall soil test with a couple little kind of results to show zero rates and high rates. And imagine that on 70 sites, 4 years in, what kind of power that data set can generate. Some of the early results that I'll share with you today was just specific to our placement methods that growers and collaborators were doing, where we took P sites specifically, kind of merged our men and conventional into one category, looked at strip-till and no-till. Now these are across 7 states, 1 province, all kind of mixed together, different P products, some MAP, some liquid, all of that, but all with similar rates and ultimate P205. And interestingly enough, we see, your no-till and conventional working with broadcast systems, and we see their ability or buffering challenges of changing 1 part per million, needing to be about 12 to 20 pounds P205 just to get 1 part per million. But yet, when you look at a banded approach, strip-till specifically, our P improves by a 5 to 8 pound, super more efficient. If you were to put that in hard product, actually pounds per acre, look at the efficiency you get out of a banded P approach versus broadcast only, especially in no-till. So just kind of, high-level numbers, but the stuff behind the scenes that are being looked at within each trial. So aggregatedly, all the trials, we can look at stuff like this, or we can drill down to specifics that are within your field, your trial. So one thing, just to talk again about kind of the innovation, thinking outside the box, it leads you to a story we did at our farm over the years of I would say fertility systems, where we were strip-till guys for about 10 years. The maps I showed you are my farms at home, so you can see the topography and the hills and valleys and fence rows and stuff. So we don't have a lot of straight edges. So strip-till for us works amazing when you're driving straight, because you can hit the strip. But the minute we had radiuses and headlands and stuff, we would miss the strip. 30K worth of GPS, still can't get it, just for struggling with it. But we realized pretty quick it wasn't the actual tillage that we were getting benefit from, it was that banded, concentrated fertilizer that we were seeing the ROI. So we run a lot of thinner, light, sandy loam soils, seeing a huge response to that. So we kind of pulled away from strip tilling, and we started using our air seeder, which is a huge case air seeder 9-time card, and we would fall band on 7.5-inch centers on all our no-till ground. We get down about 3 inches. and then we would no-till into that. And we were able to mimic what performance we were saying with strip till, okay, doing kind of 7.5-inch bands versus working a big strip on every 30. And see kind of the same crop response and efficiency out of banding that 7.5-inch P&K versus kind of working a 30-inch center 10-inch strip. Also cut my costs because I didn't need a strip till machine. Also shaved my horsepower down because I didn't need a 450 horsepower articulating tractor to drag through. So another little small shift of innovation, doing the same thing a different way, worked for us. So just a small topic on that. The importance of the point. We talked about the soil testing point being, one aspect of these trials, but the location of the point, where you pick that point, is just as important. Think about how much weight you put on that soil test. And if it's not in an area of the field that's representative of that area, you've already started out wrong. And look how many years down the road we put weight on that soil test result for recommendation, building soils, pH, all of that. If you missed the start of that, you missed a lot. If you look at a grid sample on this field, perfectly 2.5 acres. I don't know about you guys, we don't farm perfectly 2.5 acres. This farm is variable. You look at our variability map, the zone map, and it's not 2.5 acres, it's not square. It's polygons, it's hills, it's sand hills, it's valleys. You can't farm this or do a soil test in perfectly square grids when your entire range of soils and topography within that farm don't even fall within a square. So the left is a map where we actually take points specific to the polygons and the variability of the map. You superimpose on the right center mass grid samples on top, we have some pretty big errors as far as points that are completely missing high zones and low zones or in the ridges. So you're already challenged the minute you started a grid sample versus a zone-based sample. The data, you have the data. You have all the data you need to do proper polygon maps and zone maps within these fields. Coming back to the trials, this is all the other information we'd like to share. You have management zones within a field. I'd like to bring those in and start with those as well. We want to capture that variability and learn from it, not ignore it. Kind of wrapping up, our current P&K trials distributed, and we also have a new focus in our future research coming down. Starting to look at Lyme as trials, starting to look at participants to collaborate with us in that, as well as nitrogen, which with that point, I'm going to transition this into next topic. So,
thanks, Tony. Hi, everybody. My name is Nick Winkler, and this is my first time presenting at a conference, and I am just enjoying it so much. I love talking to all you guys. I hope you're having as good a day as I am. And so, a little bit about me. I am a research engineer here at Precision Planting, and I've been working for the last little bit on trying to wrangle in nitrogen, beginning to. And that includes trying to understand it, trying to figure out how to measure it, figure out how to make decisions with it. And so, I am not an agronomist, but I wanted to share a little bit about you, or with you, about my journey and some things that I found initially regarding these problems. And so I first started, back in the day, talking to growers around the country, trying to figure out what do people do practically, what do people actually do, how do they manage nitrogen. And so I had some grower conversations on the phone, and I talked to a South Dakota farmer and had asked, do you ever take nitrogen samples? Well, honestly, no, we don't. Talking to an Ohio farmer, why do you always apply the same rate each year? Well, that's what's always worked. Talking to an Iowa farmer, why do you admit to knowing that you're applying more nitrogen than the crop is uptaking, but you keep doing it anyways? Well, I don't want to get it wrong. Well, fair enough, right? Nitrogen efficiency is very costly. Totally understand that. And so I didn't get what I was hoping to learn out of those grower conversations. So I thought, where's the next place I can go? Where can I go to just get a book on this and learn? And so I went to the extension office and got the agronomy in. And so this is how it looks. This is what it looks like. And if you look in there under nitrogen management, And this is the same for most of the I states. They recommend using the MRTN calculator to figure out what rate to apply on your farm. And so a little bit about that, I went to the website and looked at it, and MRTN is maximum return to nitrogen. And here's the plot I pulled from that website. So this is just showing a little bit about the economics of applying different rates of nitrogen on your field, purely just the economics of it. And so in the orange line, as you apply more fertilizer, the total cost of fertilizer goes up. That makes sense. Blue line is yield, and that plateaus out at a certain point. You just can't keep applying nitrogen and expect the yield to just keep going. And the red line is the subtraction of the two. It's the blue minus the orange. It's outputs minus inputs. It's yield minus fertilizer. And you can see there's a point at which you're maximizing your return to nitrogen. Now there's a band to it. It's not perfect, right? That region is pretty flat, so there's some leeway to it. But for this argument, and I think in most cases, you take the center in the middle, or the rate in the middle, and that's what you use. And let me tell you, this chart makes an engineer happy. There is clear lines, a nice peak, very obvious point of where you should be choosing your rate at. And if only agriculture actually worked this way. Because the problem is that if you use this website, you have a choice between two regions in Iowa that your farm is supposed to be represented. It's either mainland Iowa or southeastern Iowa. Two regions for the entire state. And so let's look a bit into that. Let's zoom in to Iowa here. And I can kind of see what they're saying, right? The south side and the southeast side, there's more rivers, more natural greenery. Makes sense. In the mainland part, a little flatter, more prairie, a little browner. Okay, maybe they're onto something. But let's look at a random field and the most average point or average place that we find. And for me, that was in the middle of the northwestern quadrant. And so that's highlighted there. So let's zoom into that quarter section and take a look. Well, you can see there is still a little bit of variability in this field, right? So on the west side, we have some low spot. And that's why it's a little browner. And then we have speckled throughout black spots and gray spots, and those are also low spots in the field where water will pool. And if we overlay the soil survey map on top of that, well, it lines up very well, actually. As a credit to how well the soil surveys work. And so if you look at the types of soils in here, there's 5 different soil series here, 5 different map units shown. Well, the thing is, in Iowa, there's over 400 different soil seeds, and there's 5 different. So it's hard to believe, or it's hard for me to understand at least, why it's recommended on this field we apply the same rate as 3/4 of Iowa. And that's not even talking about variable rating within the field to account for those soil series differences. So I can't even imagine the difficulties you all face trying to navigate around this in your profession. And that Ohio farmer saying that, he's starting to apply, or he applies the same rate every year because that's what's worked. Well, it's kind of making sense. So let's look at it a different way, though. And from that same website, the website, by the way, is cornratecalc.org. Couldn't hit more on the nose if they tried. It's a perfect name. How often is that rate correct? That's the next question that comes to mind for me. And so from that website, they show you the frequency of times that you hit that optimal rate. So the rate that we had is shown here in the blue bin. And every time that you're over applying, that's the times in yellow. And every time that you're under applying, that's the times in red. By the numbers, by their data, 30% of the time, if you use an MRTN rate, you're over applying. 47% of the time, you're under applying. That's a huge yield loss there. And if we look at the dollars behind this, within the blue bin, you're there 20% of the time. The rest of the time, the majority of the time, you're outside of that bin. And if you're outside of that bin, you're off by at least $12.50. So the majority of the time, you're significantly off. Think about a 1,000-acre farm and being off by just $12.50. Not only that, does it stay the same year to year? Does it change next year? Well, according to a trial at Purdue, here's some research data there. They had applied different rates of nitrogen fertilizer arranged them on a field year over year and looked at how the yield responded to them for both corn on soybeans rotation and corn on corn rotation. And you can see that in both cases, the response to the same nitrogen rate changes. And just for some numbers, if you look at the orange or the red and the yellow line and say, okay, well, at what point do they both reach the same yield? There's an 80 pounds per acre difference year to year. I mean, that's huge. So, why is this happening? Well, just one reason it could be happening is what we'll talk about here. So let's come back to the basics. Let's talk about the nitrogen cycle a little bit, right? You have different pools of nitrogen in your soil, organic nitrogen and inorganic nitrogen. Organic nitrogen representing 95% of the nitrogen in your soil. That's unavailable plants. 5% of the nitrogen in your soil is actually available plants. Now there's conversion processes that happen between all of these that microbes perform, but there's also losses to the environment. There's volatilization loss, denitrification, that's just nitrogen going into the atmosphere. There's leaching, which is nitrogen washing away through your soil naturally. Every single one of these processes is not only driven, but is primarily driven by weather. Weather has a huge impact on nitrogen. And so, just to illustrate that point, I think it's very fitting that when we were reviewing these presentations, Cory's dad was texting us about how over in Western Iowa, where he farms, they were getting record rainfalls this year for the month of June. And last year, they got record rainfalls for the month of May. And this is a perfect example about how weather changes year to year and can have a huge impact because their peak rainfall occurred a month later this year. Now, do you think that the nitrogen in their soil is going to act the same way this year as it did last year? So I know I've left you with a lot more questions than answers. I mean, I, for one, am very confused by all this, but I'm just trying to do my best. And so, left you with more questions than answers, but the truth is that the answers just aren't out there, right? We're trying to find those answers. And so that's why the engineering team and I are very proud to announce that we're going to be measuring nitrate for plot trial participants on Radicle in Tremont here starting next spring. And so it is only for plot trial participants now, but we're working on it. And so thank you so much for your attention. Really had fun doing this. I'm going to hand it off to Cory here.
Okay, so getting your nitrogen rate correct is very hard. And like Nick said, it's the spatial soil variability, the spatial water variability in your fields, and the seasonal weather patterns that change, and then just the lack of guidelines and information to help you pick the correct nitrogen program rate for your fields. We started doing nitrogen trials a little more extensively this year, given the fact that we're now building it into the Radicle Lab. We want to learn for ourselves, like Nick said, what is measurable, what can we figure out in the fields that can help us find tools in the future. We're learning along the way and trying to figure out how can we do a better job at potentially providing something for you or just helping you learn a better way to figure this whole thing out. So this is some pictures from our nitrogen trial out back just this spring. Up on the screen, what I like to do every week, we go out and we pull nitrate samples to collect and build up a database on this farm. But I kneel down and I take a picture of the bottom half of the canopy in the rows of corn. And so I've got them in order from 20 pounds to 240 pound nitrogen rates in the trial treatments out there. And then we also have the corn plants over here on the left, which we went out yesterday and dug them from the field. Luckily, the weather cooperated perfectly to have beautiful weather to be out with shovels in the field for a few hours yesterday. No sweat at all when we pulled these in and got them set up here. But so from left to right, you can see the 20 to 240 pound treatments. So we're basically 40 pound increments in the total end program. And just the plant's always telling us when we run short, right? But we rarely can tell when we have more than we need. So as I look at this side where we're running short, we've got nitrogen deficiency symptoms all the way up within about 2 leaves of the ear. on the 20 and the 80-pound programs. And then as you move farther to the right, you just notice that that nice dark green color is still all the way to the ground. The plant's natural mechanism is to reallocate nutrients that it's lacking from lower in the plant and moves it up to the ear area so that it can finish out its purpose in life, which is to reproduce and produce seed for the next generation of the crop. And so that would be the grain. So just looking at pictures on the screen, plants over here, can you at this point in time tell which nitrogen program is going to hit the top end of yield and be the best ROI and return on the investment of nitrogen? You really can't, right? We don't know if 160 is going to run short yet this year. This corn is at R1 right now, so we're through pollination. We still got about 60 days left to fill the kernels on those ears. And we really can't tell if we're going to run short yet or not. So to be determined on what we learned from this trial. And again, this is kind of the beginning of many more trials and learning exercises in the future. Jason Webster up at our PTI farm, he's been doing nitrogen trials for quite a while. What you see on the graph up here is from 2018 to 2024, the rate trials that he's been learning about. So these are all applied the same way. The 3 dots representing each year on its colored line there, the middle dot is the standard rate that was prescribed for the year. So that's the rate that he picked for the season. And the dots on either side, he reduced the program by 25% and he increased the program by 25%, just because it's a nice way to learn, am I too lean or am I long on my nitrogen program, and then try to adjust each year, which he has from 2018 to 2024. What you notice on the chart, the nitrogen rates increase as you move from left to right, and the yield is increasing from bottom to top. Each year, if you look at the center point relative to the points on either side, most of those lines are going up and to the right, indicating that most years more nitrogen is generating more yield. There was only one year where it flatlined. The other interesting thing about this is I also pulled the MRTN recommended nitrogen rate for Central Illinois, which would represent our PTI farm, and it would have been around 175 pounds of nitrogen for each of these years. And so you can see that by doing the nitrogen trial, it's really helping learn that on that farm, we need more nitrogen than the average for this central part of the state of Illinois. So it's a good thing to do trials so that you can make sure that you're getting it right, and also make sure that you're not just overspending on fertilizer that's not needed. So getting the right amount for the season is a challenge, and trials really help with that. But then there's also opportunities where there's some fairly easy levers for you to pull in choosing the time and how you place your nitrogen fertilizer to optimize its efficiency and crop uptake. So the reason why timing and placement is a big deal, on the screen here, I created a 12-month counter. So from October to October is really how we think about a crop season when it comes to our corn crop. And we're putting together a plan for our nitrogen application for the year. The crop and its actual nitrogen uptake is really only happening right from emergence through the full maturity stage of R6, and we get a really rapid uptake of nitrogen from about V6 through VT, which is where the bulk of the nitrogen needs to be available within reach of the root system of the crop. So then we think about, well, what about the left-hand side of the screen? Prior to when the crop is growing, how do we think about nitrogen on that side? Well, it's about the opposite curve, right? The farther left of the corn crop growing, the farther away from that corn crop we get, the higher the risk is of loss through all the things that Nick talked about: leaching and volatilization, mineralization, soil tie-up, microbial tie-up. All of those things are factors in just reducing the ability of the nitrogen you apply to be available to the plant. So anhydrous is really common. Think about when anhydrous is applied, it's almost 8 months before the rapid uptake period that the corn crop is going through. So there's a lot of time there with a lot of risk as far as guaranteeing the efficiency of availability for the plants. And there's ways to compensate, right? Maybe your nitrogen trials and your programs are going to just push you into higher rates to overcome the risk that you're taking on, and there's a lot of reasons to apply nitrogen at different times. So not really going into that, but just illustrating the reasons why timing and placement matter. When it comes to placement, you want to think about, is it within reach of the plant itself, its root system during its different phases of growth? Any product that's broadcast on the soil surface is really not just readily available to plants. Most of that is getting consumed by the biologicals in the soil as they break down carbon and residue material, and it's also getting tied up in just the clay humus complex, the organic matter and the CEC in the soil locking up free and available nutrients to then maybe be released later on in the crop cycle. Weather patterns play a big role in the efficiency and the timing of when the soil tied up fertilizer becomes released sometime during the season. So from a placement perspective, banding some of your nitrogen near the corn plant row, increasing the ability of the plant to get access to it quickly when it's in a smaller size and has less roots, but also preventing that soil tie-up by having it in a concentrated band. We've also done 8 years of placement studies in nitrogen at the PTI farm, and this is all with 32% UAN, liquid nitrogen, and applied with these 3 different methods. So broadcast with the sprayer pre-plant, banded with a planter with conceal, and side dressed around V6 corn stage. If you haven't heard of conceal on the planter, just to give you a perspective on how it works and where it's applying the nitrogen, it's a set of knives that are integrated with the gauge wheels on a row unit. It's laying a band of nitrogen 3 inches on each side of the row and about 1 inch deep to incorporate that nitrogen to make sure that it doesn't have the risk of volatility. So those are the 3 different ways that nitrogen is being applied in these 8 years of trials. All of the nitrogen programs are roughly 240 pounds of N. So similar to the kind of the median rate on that other chart. So this is the exact same investment in nitrogen. We're just applying it differently is what we're going to evaluate. So these first 2 bars is a single application. So all 240 pounds of N applied in 1 shot. Number 1 there is all sprayer broadcast pre-plant. Number 2 is 100% of the N banded with the planter through conceal. And you can see there's a 12 bushel advantage over the 8-year average to banding near the row versus broadcasting all of it. The next set of bars is representing splitting the application into 2 different applications. And in this case, the blue bar there is significant because that's kind of the Central Illinois standard. Most guys are putting about 50% of their nitrogen on with their wheat and feed broadcast in the sprayer, and the other 50% of their nitrogen is side dressed with the toolbar later in the season. So there's an increase in efficiency and yield from the number 2 to the 1 and 2 split application, and then that 4th bar there is moving the broadcast of nitrogen to the planter. So now we're 50% planter banded with conceal, 50% side dress, and we gain another 10 bushel on top of that Central Illinois standard application method. The last bar on this chart is the triple application. So using all 3 methods of application and all 3 timing of those placements, we gain another 5 bushel beyond the dual application, and we're up to that 242 bushel. The main point here is split applying from a timing perspective, but then also incorporating some banded applications. There's a 30 bushel difference in the corn response with the same amount of nitrogen invested for the season on these 8 years of the trial. If we go to the economics from this, the Central Illinois Standard weed and feed sprayer and side dress is represented by 1 + 3. There's the black line across the center of this, and then we're looking at the return on investment as compared to that Central Illinois Standard. So that first bar there, we're losing $32 an acre in that nitrogen ROI, and that's 100% broadcasted nitrogen. And then the 2 and 3 is planter plus side dress, and then the 1, 2, and 3 is that using all 3 application timings and placements, and we're $47 an acre more profitable than the Central Illinois Standard of just weed and feed and side dress. The big key here is the fact that there's $80 an acre difference in the return on investment of the same nitrogen depending on when and how you place that nitrogen in your crop season. And that's really the takeaway for that. So why is there such an impact, and why does that triple application option have such a greater nutrient efficiency in the crop? If you think about that nitrogen uptake cycle in the corn crop, early on from emergence to V6, the common issue there is soil type. So early in the spring season, the plants are typically experiencing cool, wet weather, rainfall events, things like that. There's a common period there where the soil is actually tying up nitrogen through immobilization. And that's the phase where the planter band of nitrogen really has a big advantage to increase the efficiency and uptake. Then the middle of the crop growth stage, during that rapid uptake period from V6 to VT, this is where you need high volume, accessible nitrogen, and the side dress band really plays a big role in supplying that to the crop. And then the back end of the season, through the reproductive stages, we now have a full-grown plant, like here in the room, a massive root system, and we have soils that are going to consistently stay warm and microbially active the rest of the season, so we get a lot of mineralization. Pretty much all of the soil supply of N, as well as your pounds of nitrogen that you applied in any of the fertilizer applications, is now playing a pretty big role in finishing out the crop. So that back end is really, did you get enough total N on to go along with what the soil supplies? So that kind of wraps up. Today you have a lot of control over timing and placement, and there's huge gains to be had in how you do it. So as we wrap up our session with Tony, Nick, and I, one of the first takeaways for you to consider is participating in the nutrient crop response trials. So the reason why these are valuable is it's an opportunity to get some assistance and some help, right? Tony is an expert in agronomy, he's an expert in data science, and he's an expert in trial work. He will work with you as a partner to do trials on your farm or on your customer's farm so that you can get customized local results on how your soils are responding to phosphorus, potassium, nitrogen, lime applications on those fields. It's a great complementary value to add to the locations where the Radicle labs go to help you have custom recommendation data to work with your customers or on your own acres. Number two, the nitrate measurement is going to be new on the lab in 2026. So anybody participating in the nitrogen trials, we will run nitrates through the labs here in Tremont. And this is all effort to continue to look forward and try to grow into tools that can help in the nitrogen space. And then nitrogen use efficiency. Just trying to make that point very strong. The opportunities you have with timing and placement to maximize the efficiency of your nitrogen. Trials are the only way I know to figure out how to determine the right program nitrogen rate on your farms. So you add that to your improvement in uptake efficiency, and it's how we need to work forward to get better. Lastly, I'll have Nick and Tony come back up. To get involved, you're just going to scan this QR code up here on your phone. It's going to bring you to the Radicle Research Participation webpage. And on that webpage, you can click a button to get involved, and it'll connect you with Tony and his team to start talking about what trials might look like on your farm. So it's where you can get a lot more questions answered, and you can start stepping into this process of having customized research in your area. We got plenty of time for a few questions, so let us know where we didn't cover well, or if there's any area that we confused you on. Whether it's the P&K trials, how we're measuring nitrates, nitrogen programs, anything I didn't explain well on the screen, what's on your mind? Yeah.
How are you looking at doing live trials? I guess I'm kind of curious if you're going to be, you start with a pH that you sampled from. Are you going to be testing the lime using ag lime? Are you going to be using pelletized lime? Kind of how is that process looking?
Yeah, so obviously looking at an acidic field issue initially. And then I think what we're gonna do is pull a bulk sample from your field and bring it back here as well in the greenhouse, as well as your neutralizing product. Because it's so different across different states, areas, dolomitic, drying fineness, all that. Gonna kind of try to fight it that way, I think, start. So that makes sense. But we're gonna do more, we'll do like a small greenhouse incubation study with some field blocks with it, but we really, as a group, we kind of talked and don't realize how many amazing line products are out there. But the neutralizing capability is kind of that carbonator. We've got to be able to kind of figure out that piece too. So it'll be a bit tricky, but it'll be, like I said, it's kind of going to be one-offs. What are you working with? What's your acidity issue? What product do you have? And then, like I said, we'll do a control, non-environmental factors, and then we'll do some field stuff with it as well. If that makes sense. So. If you got an acidic field, come talk to me because we're trying to get those.
I think we took some of our soil last year.
Yeah, so we're just trying to figure out that, but if we could get on that, we'll start that process. We're ready now with the greenhouse to kind of do some of that with Brad and things, so. Yeah. Good.
Yeah, go ahead.
How does anhydrous fit into your economic nitrogen rate? Would that be more similar to a pre-applied stuff, or would that be more considered to replacing a sidedress application?
So like in the crop uptake cycle, where does anhydrous kick in? Is that what the question is? It would be similar to a sidedress application as far as the band location. Your fall anhydrous band is not accessible to the young corn plants. It's pretty common. I always think it's kind of ridiculous, but every year, sometime about knee-high to waist-high corn, you start seeing publications talk about, oh, we're in the ugly corn phase. Don't worry, it'll grow out of it. Well, it's a phase where there's been a lot of immobilization in the soil. The plant is small, the root system's small, and the corn actually starts to show some nitrogen deficiency until it gets tapped into the anhydrous in a lot of fields. And then you start seeing the corn pot green right where the anhydrous strip is, and then eventually it's only a day or two, and then it'll fill in, across all rows and all plants. But anhydrous is deeper and it's in a band, so it's not until the root system is fully tapped into that zone that it is a factor in the nitrogen uptake cycle of the plant. So yeah, you could kind of consider it is a sidedress application, but applied 8 months earlier.
Are you guys testing ammonium or just nitrate?
It's just nitrate as of right now. That's,
In our trials that we're doing right now, and sending those samples to other labs, we are grabbing ammonium and nitrate as well, so we can have the data to learn from. So just to give you a little background, we're looking at it, and
yeah, we're still trying to figure out, I mean, there's a reason MRTN calculator is recommended without anybody inputting any nitrate measurement into that. But sometimes, in some cases, it's not the most valuable in some areas. It's still trying to figure out, what measurement to take, when to take it, how many, that kind of thing. And so, yeah, we are very early in trying to wrangle in nitrogen, but it's a stepping stone.
Are you guys using tissue tests on the nitrogen as well?
I think we will do tissue tests for these, but we haven't been doing them weekly. Right? We've been pulling nitrate and ammonium samples weekly, and then we've been doing S&T samples as well. I'm still trying to understand it.
for nitrogen specific tissue I've done in the past, it's a little tough to correlate for nitrogen because it relocates in the plant. So if I pull an ear leaf on a plant that has deficiency at the bottom, the ear leaf might still have normal amounts of tissue nitrogen. So it's a top 24 tissue to be your guide, but we intend to get some data on that as well so we can include it in our research and moving forward to make sure we're not missing something.